These are the examples, and you try it from sections 5.1 to 5.3. So I'm going to work the examples, and then obviously you can do the you try it on your own. All right. So the first couple just deal with adding and subtracting polynomials, because again, Chapter 5 dealt mainly with polynomial expressions, polynomial functions, polynomial equations. So the first little topic here is just adding and subtracting polynomials, which essentially is just boils down to combining like terms, right? So really, like in example 1 here, 5t cubed plus 3t plus 4t to the fourth minus 3t cubed plus 1, those parentheses really mean absolutely nothing, and all you're really doing here is just combining the like terms. So in this instance, I would combine the 5t cubed and the negative 3t cubed, and that's it. Right? In this case, that's the only things that are going to combine, because none of the other ones are like terms. So I would just combine the 5t cubed minus 3t cubed. I get 2t cubed, right? And then everything else is just going to come down. But if you see here, and again, this isn't absolutely required, but the idea of writing in descending order, meaning you're going from the highest degree to the lowest degree. So in this case, the highest degree would be 4t to the fourth. So I'd write that first, and then I'd combine the like terms, right? The t cubed terms, and I would get 2t cubed, and then I'd bring down the 3t, because that's the next highest degree, and then just the plus 1, because that's the constant term. So 4t to the fourth plus 2t cubed plus 3t plus 1. And there's nothing else I can do there because there's no like terms, right? And then the only difference with number 2, example 2 here, is that it's subtraction. So when it's subtraction, you can see my step 1 up there. I say distribute the subtraction sign to each term of the polynomial being subtracted, right? And in this case, it is necessary. So what I would do, if you don't want to rewrite the whole thing, you can just do this. Change the subtraction to addition, and then change the sign of all the terms of the second polynomial, right? So that becomes a positive 5x squared, a negative 2x, and a positive 4. So now I would combine the like terms. So in this case, the x squared will combine with the 5x squared, the negative 3x with the negative 2x, and the 1 with the 4. And that's already, these are both written in descending order already, so it's going to be easy to keep it in descending order, right? I would just say x squared and 5x squared are going to give me 6x squared. Negative 3x and negative 2x is going to give me negative 5x. And then 1 and 4 is going to give me 5. So 6x squared minus 5x plus 5. Right? So again, essentially, adding and subtracting is just combining like terms, really. And then multiplying. Okay? Now multiplying, you just basically have to remember that each term of the first polynomial that you're multiplying has to get multiplied by each term of the second polynomial that you're multiplying. All right? And the fact that you have to add the exponents when you're multiplying terms. All right? And then occasionally you're going to have to combine like terms after you multiply at the end. Right? You might be left with like terms which then have to be combined. So the first one, it's just a monomial times a binomial. So this is really just amounts to distributing the negative AB. So what you're really doing here is you're really just doing this kind of thing, right? So you have negative AB times A squared. So you add the exponents of the A's there, and you get negative A to the third B. And then negative AB times negative B squared. Well, it's a negative times a negative, so it'll be positive. And then b times b squared is going to be b cubed. So it's ab cubed. So negative a cubed b plus ab cubed. And so that was just distributing because it was a monomial times a binomial, right? Now, when you have one like example 4 here, which is a binomial times a binomial, sometimes people will call this FOIL, right? That acronym meaning first, outer, inner, and last. But again, if you just remember what you're doing, you must multiply each term of the first polynomial by each term of the second polynomial. FOIL kind of comes about on its own, right? Like, so if I distributed the 2z, I would multiply this and this, and then if I distributed the negative 1, I would multiply these two and these two. So what have I done when I've done that? I've actually created the FOIL, right? If you want to call it FOIL, this one would be the F, this would be the O, this would be the I, and this would be the L. Okay, so the F, or the 2z times the z was 2z squared, and then 2z times 2 was 4z, and then negative 1 times z was negative z, and then negative 1 times 2 is negative 2. And then again, you see my third step up there, combine like terms after multiplying. So in this instance, my two middle terms here are like terms, so I'm going to have to combine those. So the 2z squared stays, but then 4z and negative z become 3z minus 2. So 2z squared plus 3z minus 2. Alright? And again, rather than trying to memorize FOIL, I would just realize that every term of the first polynomial needs to get multiplied by every term of the second polynomial.